Let's try to find the current and the voltage difference across each resistor. The first thing we need to do is probably determine which side to start on, which direction the circuits are going and the currents are going. So let's start with the bigger battery, and we're going to move in the direction of the electrons. So let's see, the electrons will move away from the negative, and that will tell us that the current should be in this direction. And we'll call that current C. So that means it should keep going this way and this way. And then at this point, it's going to branch off and go in these two directions. And so we know that this is like IB, and this one would be IA. And before we go any further, let's make sure that we note that IA plus IB is equal to the IC. And so when we come back around here and loop these two things together, like, let's say IB is going to come through over here, and then it's going to have to go this way and potentially that way. We know that this is IC again. If we go backwards and we work our way backwards, we know that like this has to be A plus B in order to make C. So it has to go in this direction. But another way that we can sort of figure that out is based off of the movement of the electrons again, because they're going to want to go towards that direction. But, and that means the current's also going this way. That's sort of like, you know, kind of two different ways you could try to figure that out. But anyway, let's just kind of try to figure out the next step, which is going to be which loops do we want? We need to place Kirchhoff loops. The first one's going to be around here, and the second one's going to be around here. And so we're just going to build it. And first we'll represent it, you know, really neatly with variables, and then we'll solve it real quickly with some, you know, just some equations. So we'll just say that epsilon 15, that would be this first one. We're going to follow that with the plus side, and we're going to go, notice how this is following with the current in this direction. And so that means that we're going to want to go minus the next thing, which would be IC and then RC. That's going to be this resistor. Then we're going to follow the current, and this loop is just going to take us to here. Again, we're following the current, so it's another minus. And this is going to be IB, RB. And then we're going to follow the current again, and that's going to be the end, so we'll call that 0. The next loop that we can make is this one. And we're going to say, we'll start from the battery. We'll go E12. And then we'll say, again, we're going with the current, so it's going to be a minus IA, and then RA. And then we're going to follow that this way. Here we're going against the current, so we get to add IB, RB. And then that finishes our circuit. It's going to be equal to 0. Let's try to represent these in really easy variables. You'll see how simple it'll be to solve. A plus B equals C, which we should arrange for B equals C minus A ahead of time. The other ones will be 15 minus RC is going to be 4. And then C minus RB is going to be 2. And then we'll just call that B. That's equal to 0. And then this next one will be 12 minus RA is 4. We'll call it A. Plus RB is 2. And we'll call that B equals 0. So now we kind of have 3 equations. 1, 2, and 3. And I rearranged it in terms of B, so that way I could plug that in here. But I'll multiply this by 2 first. So that would be like a 2A, 2C, and 2A. 2C minus 2A. And then we'll be able to plug that in here for these. So we'll just say that 15 minus 4C minus, I guess we'll just minus 2C plus 2A. That would be equal to 0. And then this one would be 12 minus 4a, and then plus 2c minus 2a equals 0. We could just basically put this together because 12 minus 6a plus 2c equals 0. We could see that 12 plus 2c would be equal to, actually here we can divide this by 2, so we'll just say that 6 minus 3a plus c equals 0. And that'll give us that c is equal to 3a minus 6. And then on the other one, then we can see that this is more like 15 minus 6c plus 2a equals 0. So like, 6c equals 2a plus 15. And then we'll just plug in this stuff for c. So we'll say that 3a minus 6 equals 2a plus 15. So 18a minus 36 equals 2a plus 15. And add 36 to that. It's going to be 15 plus 36, 51. So we essentially get that 16a equals 51. So a equals 51 over 16. That's going to be like current A, 51 over 16. And then we can say, let's plug that in here. So we'll get that C is equal to 3 times 51 over 16 minus 6. If we do that real quick, 3 times 51 over 16 and minus 6 gives us 57 over 16. So I guess that's what C is. That's going to go over here. Plus B equals 57 over 16. We could easily see that B would have to be equal to 6 over 16 for that to be true. And so now we should be able to find, that was the current, the 3 different currents. This we could just put I, and I again. So those are those currents. And then we're going to want to find the voltage difference as well. Well, it turns out that delta V is equal to IR. And so if we try to figure out the voltage difference, then we'll just be looking at these currents times the resistances. So we'll say that the B is equal to 6 over 16 times 2, 12 over 16. That would be more like 6 over 8 or 3 over 4. For the voltage there, I guess we would represent that by 0.75. So let's see, 0.75. We might have to add this up just to see if it's true in the end. You never know. This one would be, but the VA is going to be the current times the resistor. So we're supposed to use a calculator. 51 over 16 times 4. 51 over 4, well, it would be 12.75. All right. So VA is going to be 12.75. All right. Yeah, I mean, because you'd have to go this way, and then, you'd get, I think this is probably going to be minus when we go this way. Yeah, so you'd get a minus, and then you come through here, and this would give you a plus, so that would take you back to a 12, I guess, or that would take you back to 0, because over here you'd end up at 0, and then you go back to 12 here. So boom, that'll work. And then over here, then I mean, this would probably work out to be very close to 15 or something. Hold on. So set 57, and then we'll multiply that by 4. So 57 divided by 16 times 4, and 14.25. So VC equals 14.25. And so when we put that in here, 14.25, that should probably be minus. So that way we can come back here, and then we come through here to be another minus, which will take us negative 15. Well, that would be 0 in the end over here. So that's perfect. Yes. Crazy stuff.